So protected areas are key tools employed globally to help mitigate the biodiversity crisis and maintain ecosystem services. And their establishment is is mandated under several international agreements, which are reflected in government policy at national and local scales throughout the world. And indeed here we can see that protected areas, are the green and the terrestrial, the marine and blue, are located throughout the world, and that their coverage has been steadily increasing over the last century. And it's likely that the number of protected areas will continue to rise, driven by targets such as the Convention on Biological Diversity, which is to protect 10% of marine area and 17% of terrestrial area by 2020. So systematic conservation planning is currently the foremost paradigm under which protected areas are designed. And this approach is being employed increasingly in both a developed and a developing country context. And on the right here is Kimby Bay in PNG. So this approach essentially provides a framework and tools to guide the spatial allocation of conservation actions, and is most commonly used in relation to protected areas. So the framework outlines the main stages of planning in 11 steps and goes from scoping and costing the process to setting objectives and collecting data and protected area design and management. So stage 9 here, spatial prioritisation of protected areas or spatial design of protected areas, is a key component of planning and essentially involves getting a computer algorithm populated with biological and ideally social data and using it to work out where to put protected areas based on maximising biodiversity objectives and minimising costs to people. However, the performance of protected areas in meeting biological or social objectives is generally quite poor, and this has given rise to the phenomenon of paper parks. And in the context of conservation planning, this poor performance relates particularly to the paucity of plans which are actually successfully implemented, and this has been termed the implementation crisis. And a key factor thought to impede the success of protected areas and contribute to this implementation crisis is a lack of consideration of social factors that are related to protected areas and consideration of them in protected area design and management. And somewhat counterintuitively perhaps, protected areas are intrinsically social phenomena. They're a product of human decision making, their ultimate purpose is to restrict human behaviour, and their success is contingent on reducing changes in people's behaviour. So in order to achieve biological success, it's integral to gain stakeholders' support. So subsequently in the systematic conservation planning literature, there's been a lot of activity advocating the need to better include social considerations in planning, and most notably there was an extension of the original biocentric framework of systematic conservation planning by Bob and Madeline Bottrell in 2009 to better recognise social considerations. But in reality, social factors continue to be thought as secondary to biological, and the human dimensions tends to be oversimplified. And this is particularly true to the spatial design stage, and because this stage is such a central component of planning, this simplification tends to permeate the whole planning process. So if we go back to this framework for planning, we can see that the stages 1 to 8 are really about laying the ground for stage 9, the spatial design. So how human systems are conceived in spatial design really affects how they're thought about in the rest of the planning process, in terms of which stakeholders to involve in the process, what kind of socioeconomic data needs to be collected, and what the objectives of the planning process actually are. So let's take a look at how social factors are considered in spatial design. So these are 4 key aspects of how they are, and the first is social factors tend to be considered as costs to be minimised whilst meeting biodiversity objectives. And this puts stakeholders as antagonists to conservation, and asking people about what they want to give up for conservation is a lot less likely to garner their support than asking them what their objectives are. And importantly, research in economics and psychology has shown that people tend to weigh costs and benefits quite differently. So they tend to weigh costs a lot higher than a lot more negatively than more heavily than equivalent gains. And so people have tended to treat social factors as costs, probably based on this assumption that minimising costs will maximise social support or social acceptability of protected areas and facilitate participation. But this is quite a simplification of the determinants of people's attitudes and behaviours towards protected areas, and is based on this idea of humans as rational actors seeking to maximise their utility. But we know that this Homo economicus model of human behaviour has some problems with it, and that people's attitudes and behaviours are influenced by many other things rather than their perceptions of costs and benefits, such as norms of reciprocity and cooperation. And part of this minimising cost assumption is that the social data that we're using to represent costs is actually what people care about and value in relation to ecosystems. And most often this social data tends to be material or monetary. And again, this is a simplified way of representing the value that people gain from ecosystems, because in many places people's way of life is intimately related to ecosystems, and so they care a lot more about just the material and monetary values. And indeed, human well-being is a multidimensional concept. So there is potential for protected areas to affect many other dimensions than just the material or monetary. And lastly, stakeholders tend to be considered as a single group, and this assumes a homogeneous social structure. But in reality, we know that people's priorities for resource use and management and their capacities and powers to defend those priorities are likely to differ according to social subgroup. For example, by age or religion or gender or clan and so forth. And if this kind of heterogeneous social structure isn't taken into account, there is potential to have inequitable impacts of protected areas, which could potentially lead to social conflict and thus jeopardise biological or social success of protected areas. So this simplified way that human dimensions have been treated in planning, or in the spatial design and I guess ultimately the planning process, really inhibits the success of protected areas and the likelihood of successfully implementing those plans. And given the planned expansion of protected areas globally, there's a pressing need to better understand these social factors, including in relation to these four aspects, and how to better incorporate them into protected area design and management. So the aim of my thesis was to improve understanding of key social factors related to protected areas, including the four I just highlighted, and how to incorporate them into the design and management. So I used marine protected areas as a case study and explored this through three objectives. And the first was to investigate the social impacts of MPAs and whether these vary according to social groups. So these two data chapters shed light on the diversity of costs and benefits that protected areas can have to people, and the heterogeneous social structure of communities or stakeholder groups. And in the interest of time, I won't be talking about chapter 2. Objective 2 of my thesis was to identify the social factors related to participation in MPA management. So this chapter sheds light on the potential determinants of social acceptability or social support of protected areas, and whether it's just about minimising cost. So drawing on the lessons learned in these three data chapters, I apply them to the design of MPA networks in chapter 4. And the objective here was to test common approaches to incorporating social factors in MPA design. So I pursued these aims in the context of Southeast Asia Pacific area, particularly in Fiji and North Sulawesi and Bali in Indonesia. So there are two important reasons why my research aims are particularly pertinent in this context. And the first is that these marine resources have very high social and biological value. Many people are highly reliant on marine resources, and this area, particularly the Coral Triangle, which is highlighted in orange there, is incredibly biodiverse. And the second reason is, in order to achieve any kind of biological or social objectives of MPAs in this area, really rests almost entirely on gaining stakeholder support and really getting them to, if they want to, undertake management. So, and this is because the management rights and responsibilities here have been devolved down to local levels. And again, many people who live on the coast, their livelihoods and their ways of life are really related to marine resources. So moving on to the first data chapter, and that is looking at the social impacts of protected areas. So protected areas have had a long history in nature conservation since the 19th century, but in the 1980s the top-down protectionist paradigm began to be replaced by an approach that was, at least in principle, more sensitive to the rights and needs of local people. And this shift took in place partly because of growing concern of the disproportionate costs of conservation to poor people, but also because of rising recognition of the need to actually gain stakeholder support to achieve any kinds of biological objectives. And since then, the dual goals of conservation and poverty alleviation have underpinned much of conservation philosophy and practice in many developing countries. And this kind of integrated approach has been implemented in a number of different forms, including integrated conservation and development, co-management and community-based management. But despite this paradigm shift, the understanding of how protected areas actually affect people is quite poor. And this is because a lot of the evaluations have tended to focus on biological dimensions, and those that have looked at the social dimensions have tended to suffer from two broad shortcomings. The first is that poverty or well-being tends to be thought of in terms of a single outcome, when we know that there's consensus on the multi-dimensional nature of well-being. And the second is that few evaluations have had appropriate methods or tools to actually assess the causal impacts of protected areas. And specifically, which is most important, is having longitudinal data for project and control sites. And without this kind of data, it's possible that the estimates of impacts can be quite biased. So just to illustrate this point, if this is a data-free graph, but it's based on an evaluation from Indonesia, from Raja Ampat. And if this evaluation had just looked at what was happening in protected area sites, which is a common approach, looking at poverty trends in protected area sites over time, they would have concluded that, in fact, these protected areas were having a negative effect on fish catch. But if we compare it to the scenario of no protected areas, which are the control sites, we can see declines were a lot greater. So in fact, the protected areas were having a positive impact on fish catch, which is indicated here, and that these declines were more likely to do with broader scale trends. So this really highlights the importance of this kind of data, but it's hardly any studies actually have this kind of data. And to my knowledge, I can only think of one other study that has had this kind of data to assess the impacts of protected areas, and that was in regards to a terrestrial protected area. So I use this kind of data to ask, how do MPAs affect key domains of poverty over the short, medium and long term? I studied, to answer this question, I studied the Coastal Resource Management Project, which was a project locally known as Proyek Pesisir, which implemented MPAs in 4 villages in North Sulawesi in Indonesia. And this was one of the villages there. You can see the buoys of the MPA. So the implementation of this project was 1997 to 2002, and it was a joint project run by USAID and Indonesia's National Development Planning Agency. And it was designed to achieve the dual goals of conservation and poverty alleviation, so it included development activities such as improving sanitation, livelihood training, environmental education, and so forth. So while poverty is often conceived in terms of material or monetary assets only, we know it's a multidimensional concept. It's not just about wealth. So for example, the World Bank's definition for alleviating poverty, which is the premise of this framework, is that poverty reduction requires promotion of empowerment, security and opportunity. It's not just about increasing wealth. So I use this framework to organise the poverty indicators that I looked at. And each of these poverty domains has multiple components, which I operationalise with 14 indicators tailored to assess the potential impacts of MPAs on people. So I drew on a difference in difference design, which is like a before-after control impact design, a BACI design. And essentially this involves comparing changes in outcome indicators, here this is poverty indicators, over time between project and control sites. So to do this, myself and my co-authors, in particular Richard Polnack, collected data in 4 points in time listed here, and these were pre, mid and post-implementation. So we collected data for over 2,000 respondents for people in the 4 MPA villages and 4 control villages using mixed methods, including household surveys and key informant interviews. And this design allowed us to assess the potential impacts of these MPAs over 3 time periods listed here, which represent the potential short, medium and long-term impacts of the project. So to operationalise this difference design, I used general or generalised linear mixed models depending on the nature of the poverty indicator that I was looking at. And I found that there was a significant impact of the MPAs on 10 of the 14 indicators. So today I'm just going to show you 5 which were significantly impacted over 3 time periods. So here you can see effect sizes and the 95% confidence intervals. So the open circles are for control villages and the closed circles are for MPA villages, and the different coloured lines here represent the effect sizes for different time periods. So for example, the blue lines indicate the effect sizes or changes in poverty over time from 1997 to 2000. The black ones represent changes in poverty from 1997 to 2002, so that was the implementation period. And the red is longer term changes. So if we just take an example, which is called wealth, we can see here that there wasn't that much change in wealth in the control villages. But if we look at the project villages, we can see that there was increases in wealth, particularly during the implementation period. So this indicates that the project had a positive effect on wealth. Now there are 2 key results I want to point out here. The first is that the impacts on perceived well-being appear to be at odds with more objective indicators of well-being, such as wealth. So if we look at perceived well-being, we can see that there are positive changes in people's perceived well-being in the control villages. But these positive changes are not reflected in the MPA villages. So this suggests that the project was actually having a negative effect on people's perceived well-being. The other key result I want to point out here is that for a number of these indicators, including fisheries dependence and wealth, there was positive changes during the implementation period, but these changes weren't always sustained and didn't continue to accrue post-implementation. So we can see that the effect sizes are going back a bit. So returning to that first key result, so it appeared that the project was having a negative effect on people's perceived well-being, and this was at odds with the apparent positive effect it was having on people's objective well-being, so for example in relation to wealth. And this first indicates the inadequacy of the predominant approach of considering poverty only in terms of a single outcome, most often wealth. And while I tried to account for the multidimensional nature of poverty, looking at 14 indicators, obviously there are many other dimensions which I didn't look at, which could have been affected by the protected areas and which could have helped explain why we were seeing this negative impact on perceived well-being. And one of these dimensions is conflict. And while I was in these villages, I heard many stories of conflict in relation to the MPAs, for example, in regards to poaching. And in one village, the whole MPA management board protested against their inability to effectively prosecute poachers by fishing together in the MPA. So to reduce this kind of conflict, it's really necessary to foster relevant governance mechanisms such as nested institutions and graduated sanctions. So moving on to this second key result, that the MPAs appeared to contribute to poverty alleviation during the implementation period, but these improvements didn't seem to continue to accrue post-implementation when external support withdrew. So this finding really suggests that short-term approaches such as this, which was 5 years in implementation, can provide a short-term boost to the system, but are insufficient to catalyse ongoing activities and continual accruement of benefits. And a lot of these kind of protected area projects that are funded by international agencies in developing countries take this short-term approach of 3 to 5 years implementation period, but assume that once they leave, once external support has been terminated, that project activities and related benefits will continue. So this research really questions the efficacy of this short-term approach and suggests that donor agencies and implementation agencies need to get a little bit more realistic about the time it takes to achieve different kinds of biodiversity and social objectives. So I'm not going to talk about this chapter in detail, but just briefly, here I looked at the same project as the one I just talked about in North Sulawesi, and this time I looked at whether those impacts that I was speaking about differed according to social group, and specifically according to age, gender and religion. And I found that there was some evidence that the impacts of the MPAs differed according to these different social groups. So this highlights the importance of considering and recognising the heterogeneous structure of these communities and stakeholder groups in order to avoid potential inequitable impacts of protected areas. So moving on to the third chapter, which is about participation in community-based management of MPAs. So in the 1990s, there was decentralisation reforms in many developing countries, led to natural resources being management under institutions promoting devolved decision-making and participation of local people, such as community-based management or co-management. And so devolved decision-making in relation to natural resources is where the management rights and responsibilities have been devolved down to local non-government groups. So, for example, user groups. So as we'd expect, devolved management is underpinned by local participation, and many studies have shown that critical to the success of these kinds of natural resource management is the extent of local people's participation. However, our understanding of the social factors influencing individuals' decision to participate is actually quite weak. And that's because a lot of research on devolved management that has been sort of trying to understand participation has used communities as a unit of analysis. So they've been looking at what kinds of factors influence communities to collectively manage their resources. So that's a lot of the work from common pool resource literature. And the few studies that have looked at why individuals participate in management have tended to look at the influence of factors at the individual scale or a single scale. But we know that individuals are nested within communities and that their behaviour is going to be influenced by characteristics of themselves, but also of the people around them and of their wider community. And much of this devolved management research has been undertaken in regards to terrestrial commons. So to help address this gap, I asked how are community and individual scale social factors related to individual participation in community-based MPA management. So I took an interdisciplinary approach in addressing this aim and drew on the social ecological systems framework, the theory of planned behaviour and public goods schemes. So the SEAS framework from the literature on common pool resources essentially depicts how human interactions and outcomes are influenced by characteristics of the social ecological system, which are divided into 4 different subsystems which are highlighted in green there. And one such interaction is participation, and in our case, participation in MPA management. So I use this framework to structure my analysis. And specifically, I drew on the variables that are specified for the governance and user subsystems to inform my choice of the factors that may influence participation. So again, this framework is tended to be applied using communities as a unit of analysis. So a lot of the factors that are specified in this user system are at that community scale. So to guide my choice of individual scale factors that may influence participation, I drew on the theory of planned behaviour and public goods schemes. So the theory of planned behaviour is one of the most widely used models of behaviour from social psychology, and suggests that behaviour, in our case participation, can be predicted from 3 beliefs. Normative beliefs, which is people's perceived social pressure for them to undertake the behaviour. behavioural beliefs, which is their perceptions of the costs and benefits to them of undertaking the behaviour, and control beliefs, which is whether they feel like they have the ability to undertake that behaviour. So public goods games I use that kind of game to understand cooperative behavioural disposition. And I did this because whether people are cooperators or non-cooperators is thought to be highly related to whether they're going to be participators or not participators. And public goods games are one of a number of games which are used in behavioural economics to understand behaviour in regards to social dilemmas. So social dilemmas are situations where group outcomes conflict with individual outcomes. Or in other words, where acting selfishly can give the individual a great outcome unless everyone else in that situation acts selfishly, and then everyone loses. So this kind of game is appropriate for understanding cooperation in regards to MPA management, because in principle, MPA management is a public good. And these kinds of games have tended to be played with students in labs. So a recent or more evolving area of behavioural economics is playing these games with people in the field and trying to assess their external validity. So this is whether there is any relationship between behaviour in the game and real-world behaviour. So returning to the SEAS framework with which I structured my analysis, we can see that participation goes in this interactions box, and that individual scale characteristics of the user system included these things, these are the ones I looked at, as well as these ones drawn from the theory of bland behaviour, and cooperative disposition as indexed by the public goods game. And I looked at these community scale characteristics, and in particular I drew on Ostrom's 8 design principles to inform my choice of variables for the governance subsystem. So just to refresh you on the question I'm looking at here, and that is to look at how all these things are related to participation. So what are the effects of these factors on participation? So I collected, and my research team collected this data for 264 respondents in 13 villages in North Sulawesi. And we used key informant interviews, the public goods game, and household surveys. So this is a picture of me explaining the public goods game. And essentially what the game involved was giving participants a sum of money, and they could choose whether to keep that money or put it in a common pot or a public good, and that their payoff at the end of the game would depend on how much all the other players in the group had put in that common pot. So to assess the relationship between these social factors and participation, I used the general linear mix model with Bayesian estimation. So again, you're looking here at effect sizes and 95% Bayesian confidence intervals or uncertainty intervals, and where those lines don't overlap this central zero line, it indicates there was strong evidence of an effect. So there's a lot going on here, so I'm just going to point out 3 key results. And the first was that participation was related to whether the MPA management group was a nested institution. So whether they got support from external institutions. And also participation was strongly related to subjective norms or normative beliefs. And lastly, there was some suggestive evidence, not strong evidence, that participation was related to whether people were cooperators or not. So participation was more extensive if MPA management groups were nested institutions. And in this context, it means that they were getting support from outside NGOs. And in villages where participation was high, these activities included a number of different things, but importantly, none of it was material or monetary support. And this result adds support to the importance of nested institutions, as outlined in Ostrom's 8 design principles, and echoes the previous chapter that ongoing external support from NGOs is critical to achieving success. So participation was also more extensive if people perceive social pressure to participate, and this is the normative beliefs thing. So This is likely to have been important due to strong motivations of people to comply with the expectations of their families and leaders, because Indonesian society is fairly family orientated and quite hierarchical. So in villages where participation was high, these NGOs were capitalising on this and working quite strongly with quite closely with leaders, particularly religious leaders. So, for example, in Bali, the dominant religion is Hinduism, and in those villages, the NGOs were working quite closely with the local Balinese Hindu religious leaders called adats. And here we are talking to the adat in glasses there, and they were quite involved in the management process. And for example, there was religious blessings with the opening of these MPAs. And here we can see that this religious structure was built right next to the MPA hut. This Daya Perlindungan Laut is Indonesian word for MPA. So given that nature is quite revered in Hinduism, it's quite likely that a lot of the existing religious norms are fairly conducive to marine management in this area. So this highlights the importance of identifying and working within existing norms and institutions. And lastly, I found that there was suggestive evidence that people who were cooperators were participators. Now, there are two potential reasons why I didn't find strong evidence of this, and the first is that potentially the game lacked external validity. So people's behaviour in the game didn't reflect people's behaviour in real-world decision-making. And these games are necessarily highly simplified versions of reality, so this game may not have adequately reflected the real-world decision-making environment. And studies in relation to looking at the external validity of these kinds of games have found mixed findings in this regard. And the second reason is that potentially the game did actually accurately capture people's cooperative behavioural disposition, but the problem was that MPA management was not considered a pure public good, which was reflected in the game. And this could be because in some villages there was a provision of private benefits that could have dominated over public benefits and could have precluded pro-social behaviour and motivations. And studies of resource management have found that this can be the case, and that externally provided material incentives or private benefits can actually be counterproductive. They can preclude pro-social or pro-environmental behaviour and actually raise expectation of this externally driven management. So this study provides insights into the conditions which foster participation and can potentially be used to identify opportunities for conservation and the factors which could be leveraged through management to encourage people to participate in devolved management. And importantly, this study also suggests that it's important to consider mechanisms other than material incentives to encourage participation, and while these material incentives are sort of the typical approach which is used. So moving on to the last chapter, here I'm drawing on the lessons that learned in the previous chapters and applying them to MPA design. And I'm going back to those 4 aspects of how social considerations are treated in planning. I'm just going to look at these 3 for this chapter. So, as I said earlier, social factors tend to be considered as costs. And as we've seen in the previous chapters, there's a diversity of costs and benefits that people can receive from protected areas. So this cost approach has tended to be applied in planning using an algorithm called MarkSan. But recently, another algorithm called MarZone has been developed, which allows planning based simultaneously on biological and social goals. And this approach hasn't been applied all that much, and when it has been, it tends to be applied in regards to looking at its utility for planning for multiple management zones. So to date, there is no robust evaluations of considering social factors as costs or as objectives. So stakeholders tend to be considered as a single group But I found in chapter 2 that stakeholders can have a heterogeneous social structure, and this can influence their resource use and the way that they respond to management and potentially how they are impacted by management. So there has been some work in systematic conservation planning trying to account for the multiple groups within stakeholder groups. For instance, Rebecca Weeks' work in the Philippines. But to date, no work has looked at how treating stakeholders as single versus multiple groups in a costs versus an objectives approach affect planning. And lastly, the previous chapter we just went through shows that there is social determinants or determinants of the social acceptability or support and participation of protected areas isn't just about minimising cost. So there's a diversity of determinants of whether people will support these kind of protected areas, and one such a determinant is social equity, and that's what I'm going to look at in this chapter. So that previous work I just highlighted in planning that have been looking at multiple groups, how to incorporate multiple groups into planning, has looked at equity, but to date no study has looked at the trade-offs between achieving biodiversity, livelihood and equity objectives using tools that managers commonly use to design protected areas. So the question here I've asked is, how does treating social considerations as costs or objectives and treating stakeholders as single or multiple groups affect MPA design in terms of trade-offs between biodiversity, livelihood and equity objectives? So I used the design of no-take marine protected areas for a coral reef system in Kumbalau in Fiji as a case study. And the biological data I used here was habitat data from the Millennium Coral Reef Mapping Project, which identified 9 classes of habitats. And the livelihood data that I considered here was fin fisheries livelihood data, and this was represented by spatial catch per unit effort data. And this data was collected by the Wildlife Conservation Society, and they asked fishers questions such as where they fished, how much they caught, and what kinds of gears they used. And in this area, 6 kinds of gears tend to be used, including these ones. They can be used in different places. So, for instance, Hawaiian sling, which is a less powerful version of a spear gun, tends to be used in more inshore areas. So there is potential for inequitable impacts of MPAs if this spatial demarcation of resource use according to the gear type employed is not taken into account. So MPAs could potentially inequitably impact people who employ different kinds of gears. So to assess how the designs that I produced, how equitable they were in relation to this, I examined equity in terms of the percentage of retained CPUE outside of MPAs for the 6 gears and measured it using the Gini coefficient, which is a widely used measure of equity that tends to be applied to wealth distributions. So I looked at 4 scenarios for incorporating socioeconomic considerations into planning, and these were different combinations of treating socioeconomic data as costs versus objectives and stakeholders as multiple versus single groups. But before I go into these, I just want to point out that the biodiversity objective for all of the scenarios was the same. And this was equal representation targets. So, for example, for our lowest biodiversity objective, it was to ensure 10% of the area of each of the 9 habitats was within an MPA. And I actually looked at these scenarios for 8 different biodiversity objectives ranging from 10% to 90% in order to examine trade-offs, and that will become apparent when we get to the results. So going back to this first scenario, this is a typical approach that tends to be employed in planning, and here stakeholder groups are considered as a single group and done so by summing the CPUE values to form a single value and then treating that as a cost to be minimised whilst meeting biodiversity objectives. In this scenario, I tried to take into account that stakeholders are multiple groups by first normalising the values of the CPUE before summing them to form a single value. And this single value is required, or single data layer is required under the cost approach. So by normalising them, it gives them more equal weighting in the analysis. And again, this total normalised sum CPUE was treated as a cost. In this scenario, I again treated stakeholders as a single group by summing CPUE value to form a single data layer, but this time I used this data in an objective sense. So I set an objective here to ensure that a minimum of 90% of total CPUE was retained outside MPAs. And in this scenario, the objective multiple scenario, I treated stakeholders as multiple groups by treating the CPUE data for each of the different gears separately and setting explicit objectives for each of those different gears. And that was to ensure that a 90% of the CPUE of each of those gears was retained outside MPAs. So we have the data and we have the scenarios. To plan the protected areas, I use MARZone for the objective scenarios and I use MARCSAN for the cost scenarios. So here are some results, and on the x-axis you have biodiversity objectives, and on the y-axis you have the percentage of CPUE retained outside MPAs. And the different lines here relate to the different kinds of gears. And the horizontal grey line represents the 90% livelihood objective. So what I want to point out to you here is that these trade-off curves are concave. So this indicates that low to mid-range biodiversity objectives can be achieved with relatively little loss to CPUE. But importantly, the severity of those trade-off curves actually differs between the scenarios. So we can see that here, under the cost single, the typical approach, they're most severe and they're least severe under this objective multiple scenario. The other thing is that the difference between the different coloured lines of the different gears within a scenario actually differs between scenarios. So here, under this cost single scenario, we can see there's quite a big difference between the coloured lines. Whereas here, we can see that there is not so much difference between the coloured lines or the CPUE lost for the different gears. So this indicates that this scenario produces MPA designs that are likely to be more equitable. So let's just now see what's happening in terms of equity as indexed by the Gini coefficient. And again, we have biodiversity objectives on the x-axis, and on the y we have the inverse of the Gini coefficient, where 1 actually indicates perfect equity. And what we can see is that the scenarios which produce the least equitable designs are these ones here with the black squares, which are the cost single scenario. And the scenarios that produce the most equitable designs are those under objective multiple. And now if we look at how much these MPA designs were costing in total, so how much CPUE was left outside of the MPAs, or the cost is how much was actually inside the MPAs. And this is a measure of efficiency. And we can actually see here that the most equitable solutions, which was those objective multiples from the previous slide, are actually the most efficient. That's the dotted grey line here. So they resulted in the least amount of CPUE inside MPAs. And that the least equitable was also the least efficient, and that was designs produced under the cost single scenario. So a barrier to incorporating equity in the past in planning is this sort of assumption that equity may compromise efficiency and may cost more. But this research here suggests that this isn't always the case, and in fact the designs that were the most equitable designs were in fact the most efficient. And the concave trade-offs were most severe when stakeholders were considered as a single group and social data was considered as costs. And they were least severe, so trade-offs between competing objectives were least severe when under the objectives multiple approach, which is where social data was considered as objectives and stakeholders as multiple groups. So while the trade-off curves are going to differ with context, this study suggests that the protected area designs produced under this typical approach of treating social factors as costs and stakeholders as a single group could result in suboptimal plans with unnecessarily hard trade-offs between competing objectives. Importantly, these alternative methods for incorporating socioeconomic data require similar kinds of data and similar skills, but they can result in designs with potentially very different impacts to local stakeholders. And incorporating stakeholders in a more meaningful way in spatial design through these stakeholder-specific objectives, which was the objectives multiple scenario, could potentially better facilitate win-win outcomes in terms of biodiversity, livelihood and equity objectives. So pulling this all together, my thesis contributes to conservation planning theory by elucidating important human dimensions related to protected areas and how they may be better incorporated into the non-spatial and spatial aspects of protected area design and management. And more nuanced understanding and incorporation of social factors into protected area design and management, it will help us ensure these tools actually contribute to people's well-being, which will increase the likelihood of gaining their support on which conservation success is predicated. So these are the publications that have come out of my thesis, and the first one here is published in Global Environmental Change, a couple are in review, and the last one here is in press in Conservation Biology. And I was lucky during my candidature to have some opportunities to collaborate with other people, which arose in a few other publications. And lastly, I'd just like to thank my supervisors, Bob and Josh, for all the guidance and the opportunities they provided me with, as well as Natalie, Ban, and my other supervisor, who is in, who used to be here, but currently in Canada, and Nadine Marshall from CSIRO sitting up the back. And to thank the Centre for all their support, including financial support, as well as other funding from CSIRO and the Australian Federation of Graduate Women. And my collaborators in Indonesia and Fiji from the Wildlife Conservation Society and Reef Check, and everyone in Program 6 for their camaraderie, and most importantly to the people who participated in my research, including these women down here. Thanks very much.